Hello, in this video we're going to be looking at some common physics symbols. Now, learning physics is a lot like learning a new language, complete with its own alphabet. And unfortunately, we don't just have the Latin alphabet, we have the Greek alphabet as well. And although that looks like a lot of symbols, it's still not enough. There are more physics variables than there are symbols, so not every symbol is going to have a unique identifier. We'll be looking at some examples of this today, as well as some exceptions where you do have a unique identifier, as well as some other conventions regarding subscripts. So when you're looking at an equation or how a symbol is used, the most important thing to note is the context. The context is going to tell you a bit about that symbol and how it's used. Again, not every symbol is going to be uniquely defined. One example that you'll see when you get started in physics is x being a variable for the position, but x is also used for multiplication. Another one, you'll see m used for mass or m used for the unit of meters. One recommendation is when you start learning physics and learning equations, it's very important that you learn those equations in terms of words first before you start worrying about the symbols. It's the words that give the equation meaning. The symbols are just there for shorthand once you get those equations. So again, learn them in words first. So let's go to that variable x used for multiplication. Now, since x is used as an early variable for position, it's easy to get it confused if you start using both the variable x and multiplication x in the same context. So when you get started for basic multiplication, use the dot for multiplication. Later on, when you get to vector math, the x will take on a meaning for the cross product. But as you get started, just use the circle for multiplication. It will avoid a lot of ambiguity. Next, let's look at some subscript conventions, because along with the different symbols, you'll see subscripts used in numerous ways in physics. First, or in most simplest case, is when you have just multiple variables of the same type. So you can have A1, A2, A3, just meaning the first value for A, the second value for A, third value for A, or the first variable A, second variable A, third variable A. You'll see this used for forces. When you do a sum of the forces, is the first force plus the second force plus the third force, labeled in this way. Another convention that you'll see is for the initial and final values of a variable. You'll see the subscript O or subscript 0 for the initial value of a variable, and the subscript F, both uppercase and lowercase, used for the final value of a variable. Occasionally you may see I used for the initial value, but that's also used in other contexts. But subscript 0 or O is the initial value, subscript F is the final value. The last set of subscript conventions that you'll see are for the components of a vector. You'll see either the XYZ convention or the IJK convention. When you have a subscript x or I, that means the x component of a vector. Subscript y or j means the y component of a vector, and subscript z or k means the z component of a vector. Now, as I mentioned before, not every symbol is going to have a unique identifier, but there are a couple of exceptions to this. The first one that we'll mention is the simplest case, which is the capital Greek letter sigma, meaning sum of. So when you have a sigma next to a variable, that just means you're adding all the variables of that type. So, for example, one of the first ways you'll see this in physics is the sum of the forces. Sum of the forces, F, is the first force plus the second force plus the third force, and so forth. So again, capital Greek letter sigma is the sum of whatever variable type that follows. The next symbol that typically has a unique identifier is the capital Greek letter delta, which means change in. And change in means the final value minus the initial value. So for example, delta x means the final value of x minus the initial value of x, and you can write that in shorthand with the subscripts. So delta x equals xf minus x0, and you'll see delta used throughout physics in a wide variety of contexts. But again, capital delta is change in, or final value minus initial value. The two things to keep in mind when you're learning these different symbols and knowing how to apply them is, one, just pay attention to the context and where the symbol is used. And secondly, when you learn equations, learn them in terms of the words before you worry about the symbols, because the words are what give the equations meaning. The symbols are there for shorthand once you understand them. So thank you for watching. I hope to be posting more physics videos here in the future.